Okay, so today we're going to talk about arithmetic sequences. And we've talked a little bit about them already and how an arithmetic sequence follows really a linear model. So you're going to kind of associate this with lines. However, keep in mind that you don't connect the points or the dots if you were to graph the sequence, because remember, n has to be a natural number. So for this first example, or first of all, let me talk about the formula. So we have to get the nth term. So remember that any time, because some of the homework problems are going to ask you to find the nth term. So anytime they ask you to find the nth term, that means you are finding out an expression for a sub n. So just kind of keep in mind when you see those directions. So to find the nth term, remember a sub 1 is the first term, n is how many terms we have in the sequence, and d is and sometimes we'll have a value for that we can plug in, not for a sub n. And d is, remember, our common difference. So that is the part right here. So for this first problem, we're asked to find the common difference. So notice on here, from 20 to 13, it's going down by 7. From 13 to 6, it's going down by 7. From 6 to -1, it goes down by 7. So my common difference, d, is -7. Now, the reason why it's called a difference, and because sometimes we think of, okay, I add a -7, add a -7, but the reason it's a common difference is because 13 minus 20 is -7. 6 minus 13 is -7. So that's why it's called a common difference. Now, that's all we were asked to do, but what if we were asked to find the nth term? So then we would take a sub n equals a sub 1, which is 20, plus n minus 1 times the common difference, which is -7. Now, when you write this, don't just do this, because that makes it look like it's subtracting a 7. It's times d. So make sure you put parentheses on that, because if you're going to leave your answer like that, then you absolutely have to have parentheses like that, or it's kind of indicating subtraction instead. So if you were to kind of simplify this to get it into a linear format, you would distribute here. So we would have 20 plus a -7n, and then that's going to make this plus 7. So a sub n is -7n plus 27. I don't mind you leaving your answer in this other format. Like I said, you'd have to have the parentheses there, or you could put the -7 in the front if you prefer. That's fine too. If you simplify it to this, remember that the common difference is like the slope of our line. So if you want to relate that to something that you are familiar with, that's what you would do. Okay. On this next example, we are asked to find the first 5 terms for each arithmetic sequence. So we've got 2 different problems here we're looking at. So if the first term is -14 and the common difference is 6, then we're just going to have a -14. And if you add 6 to that, you get -8. And you add 6 to that, and you get -2. And you add 6 to that, you get 4. Add 6, you get 10. So that really satisfies what we were asked to do in the problem, and that's okay. You can also actually find a sub n, but we'll have some opportunities, some other opportunities to do that. So some of the problems you might just be asked to find the terms. On part B, you're told that a sub 1 is 1.5, so that's our initial term. And then you're going to subtract, you're going to add -0.5, so subtract 0.5, and we get 1. And then add a -0.5 or subtract 0.5, and we get 0.5. And so the next term would be 0, and the next term would be a -0.5. So I'm just going to do this for part B, is actually find the formula for the nth term, just to make sure that we practice that, even though the directions on this particular problem didn't say that. So to find a sub n, remember it's a sub 1 plus n minus 1 times the common difference. So we're going to have a sub 1 is 1.5 plus n minus 1 times -0.5. And again, you could leave it like that if you want to, or if you distribute here, we get 1.5. Let's make that we'll make that a minus 0.5 n plus 0.5. So we get a sub n equals, and if you wanted to put the variable portion first, the negative 0.5 n plus 2. And that would be our expression for a sub n. So for this problem, we are asked to find a sub 16 and a sub n for this arithmetic sequence. So notice if we take 20 minus 23, we get negative 3. And I'm going to check one more. 17 minus 20 equals negative 3. Now, I wouldn't necessarily have to check both of those since they already told me it was arithmetic. Sometimes you're going to have a sequence and you want to show that it's arithmetic, and this is what you would do. So we know that D is negative 3. So now I'm going to look for a sub n first because I don't want to continue to subtract 3 each time for 16 times. So I'm actually going to find a sub n and then use my formula to find a sub 16. So we know a sub n is a sub 1 plus n minus 1 times d. So that, well, we actually could find a sub 16 first by doing this. So I'll do it this way. So a sub 16 is a sub 1, which is 23, plus n minus 1. Well, remember here, n is 16. So 16 minus 1 is 15 times my common difference. So I get 23 minus 45. So then my answer is negative 22. So we could do that. And then if we want to find, in general, the nth term, a sub n equals 23 plus n minus 1 times a negative 3. And I'm going to simplify that a bit. So I'm going to have a negative 3n plus 3 when I distribute. So I get a sub n equals negative 3n plus 26. All right, so for this next example, we are asked to find a sub n and a sub 10 for the arithmetic sequence having a sub 4 equals 18 and a sub 5 equals 22. So notice that we don't know a sub 1. Just keeping in mind the formula for a sub n, it's a sub 1 plus n minus 1 times d. And in this case, we don't know a sub 1. We also don't know d. So what do? Well, remember that arithmetic is kind of like a linear function. So we can think about ways that you would find the slope if you were looking for the slope of a line. Well, we know that the fourth term is equal to 18 because a sub 4 is 18. So that tells me the fourth term is 18. And we also know that the fifth term is 22. Now, you could have actually probably realized this just from looking at it. From the fourth term to the fifth term, you're only going up one term. And notice that you're going up 4. So the common difference has to be 4. But sometimes you're not told subsequent terms. There might be a gap in between there. So you can treat it like the slope, rate of change of the, kind of like the y values over the x values. So same idea. So we get 22 minus 18 over 5 minus 4. So our common difference is 4. So that's a way that you can do that. So now we know that part. So we know that a sub n equals a sub 1 plus n minus 1 times 4. So we know that much. So now we still don't know a sub 1. So, but I do know that when n equals 4, that a sub n equals 18. And I could have said that when n equals 5, a sub n equals 22 and done the same thing. So I'm going to take those values and plug them in. So I'm going to use, in place of the a sub n, I'm going to put an 18. I don't know a sub 1. In place of the n, I'm going to put a 4. So 4 minus 1 is 3. So we get a sub 1. We're going to have 18 minus 12. We get 6. So now I know a sub 1. So now I go back to my formula for a sub n. And I know a sub 1 is 6 plus n minus 1 times 4. And now I have my formula. I'm going to just simplify that a bit. So we get a sub n equals 4n plus 2. Now, notice that we were also asked to find a sub 10. So be careful when you're doing these problems that you look and check, did I answer the whole question? Because you're not done yet. So now we need to find a sub 10, but that's easy to do because we can just plug a 10 in and we get 42. And now we're done. Okay, so this next example is kind of like what I alluded to earlier. We're going to have to find the common difference. So we're going to treat this, we're going to think about this like the point when n equals 6, a sub n is 9. And when n equals 15, a sub n is negative 36. So finding the slope is going to tell us the common difference. So the common difference is negative 36 minus 9 over 15 minus 6. So we end up with negative 45 over 9, which is negative 5. So that's my common difference. So then I'm going to go to my general formula. So a sub n equals a sub 1 plus n minus 1 times negative 5. Notice the parentheses I used. So since I don't know a sub 1, that's what I need to find. I'm going to think about the fact that when n equals 6, a sub n equals 9. So I'm going to use those values. So I'm going to have 9 equals a sub 1, 6 minus 1 times the negative 5. So we're going to have 5 times negative 5. So then a sub 1 is 34. So we've got that. So now I go back to my general formula for a sub n. We have 34 plus n minus 1 times negative 5. So a sub n equals 34 minus 5n plus 5, or negative 5n plus 39. Okay, then double checking. I wasn't asked to find any other thing. Oh, as a matter of fact, I wasn't even asked to find a sub n. I was asked to find a sub 1. So honestly, I could have stopped there. Sometimes when you don't read the directions, you do more than you were asked to. But that's okay. You're never penalized for doing more as long as you do it correctly. This one is not in your packet, but I wanted to do a problem like this. So on page 901, number 44, they give you this sequence of an expression. It's algebraic expressions, but we are told that it's an arithmetic sequence. You are asked to determine the common difference, the 5th term, the nth term, and the 100th term of this particular arithmetic sequence. So if we try to find, we're told it's arithmetic, so that means if I take subsequent terms, if I take negative t plus 3, and I'm going to subtract the preceding term, whatever I get is going to tell me my common difference. You could probably see what it is already, but I just want to show you that you could do it this way. So we get negative t plus 3 plus t, the t's cancel, and you see that our common difference is 3. And you can kind of tell that. We add 3, then to get the next you added 3 to the previous one. But algebraically, you can set it up this way. So d, the common difference, is 3. Now we're asked to find the 5th term. Well, we already know that this is the 1st term, this is the 2nd term, this is the 3rd term, this is the 4th term. So without even coming up with a formula, you can see the 5th term, we're just going to add 3 to that and get negative t plus 12. So that one's no big deal. So then you're asked to find the nth term. So that means we need to fit it into this model. Okay, so a sub n is a sub 1, which we know is negative t, plus n minus 1 times d, which we know is 3. And you could either leave it like that or you can kind of distribute. If you do, you're not going to have like terms anyway, so we can just leave it like that. And then find the hundredth term. And to find the hundredth term, we're just going to substitute in 100. Oh, I don't know why I did that. All right, so we're going to take negative t, remember we're plugging the 100 in for n, plus 100 minus 1 is 99, times 3. So then a sub 100 is negative t plus 99 times 3 is 297. And that would be your answer for the 100th term. So I think that is all you would need to complete today's assignment. So I'll have that posted, and if you have questions, you'll be able to ask them in class tomorrow. And then we'll be going on to arithmetic series next.